Welcome to Immersed in the Metaverse. Today is our third in a sequence of four, the on-ramps to AR and VR, the on-ramps to the Metaverse. Our monthly seminar series is really focused around immersive technologies, new modalities for manipulating the virtual world, interacting with the virtual world, and looking at how those innovations are impacting science and engineering and art. We try to have a mix of lectures and demonstrations and tutorials to give you a sort of a deep dive. Immersed is sponsored by the Immersion Lab. The Immersion Lab is a central facility at MIT to provide the space, the tools, the expertise, the facilities to bring together researchers and artists looking at creative projects that benefit from the application of AR and VR and gaming technologies into education and research in art and science. So we're joined today by Thales Rex, who is the AR, VR gaming big data technologist in the Immersion Lab. And then also our special guest, Lucas Bene. He's a freshman at MIT. And he'll talk a little bit later on about VR hardware and sort of content creation. He has a YouTube channel, Lucas VR Tech. And today we're going to get a little bit of a feel, sort of a very tangible feel for both what Haptics is all about, what we're doing in the Immersion Lab, and quite importantly and quite excitingly, what Lucas is doing. So with that, please, participants, feel free to chat your questions. We'll try to answer them in real time as we go, and we'll have questions and answer at the end. Thales, take it away.
All right, everybody. Well, welcome. Hello, and welcome to Immersed in the Metaverse. So my name is Thales Rex. I am the technologist here at the Immersion Lab at MIT.nano. And so welcome everybody who are joining us for the first time, and welcome back to those who have been following this series. We are now on our third part of our four-part series about starting our conversation about the Metaverse, some of the development tools and ways of kind of creating our own content and thinking about what this means for the future. Today's discussion is immersed in the Metaverse, specifically haptics, getting kind of a sense of feel for the Metaverse and what that means, and some of the tools and the devices that are currently being developed to make that happen. This discussion today will be set up a little bit differently than our previous series, given that we have an awesome guest speaker who will be sharing his thoughts, development, and vision of haptics as we kind of move closer to the Metaverse and interactions within the virtual space. So today, just a quick overview of what we'll be discussing. We will just do a quick recap about the few seminars in case anyone missed the previous ones, or if anyone wants a quick refresher, and then we will dive right into haptic technology. I will share a little bit of some of the use cases and some of the devices that we've investigated, both here in the Immersion Lab, as well as other companies out there that are driving their innovations forward. I will then kind of bring it over to Lucas. He will kind of, again, talk about his experience and his development, and then hopefully we'll have enough time at the end for questions and more of a discussion opportunity for you attendees. So with that being said, I think we can start right in. So as some of you may already know, this is a four-part series where we kind of journey through just a sliver of the Metaverse and what is possible and exciting as we look forward to its creation. So we started discussing avatar creation and the fabrication of these photorealistic avatars using free online tools that anyone can use and customize. We then talked about the motion and animation for those fabricated avatars using open animation packages on Unreal Engine's marketplace, and how here at the Immersion Lab use motion tracking and our OptiTrack system to kind of expedite that process and customize our own animation sets, if you will. Today, we will talk about haptics and its current state in today's technology, as well as some novel developments that can be shared through the eyes of Lucas. And lastly, next month, we will then discuss kind of the virtual worlds, the research behind all of this, and what it means to put all of these pieces together towards the Metaverse and game development. So before I go straight into haptics, I will just kind of give a quick highlighted overview of the things that we discussed. Part one, we used MetaHuman Creator for content creation. We then discussed kind of the NVIDIA's Omniverse platform using the Audio Two-Face application, which is that application that we use to formulate facial animations using artificial intelligence to infer facial characteristics through just audio alone. We kind of glanced on the USD, the Universal Scene Description file format for collaborative and custom workflow for content developers. And then we discussed Unreal Engine, choosing this as our primary game engine for this series to put all of these pieces together and to create kind of our virtual scene. So here are just some images of things that you may have missed with kind of the link on the top left to our YouTube video if you are interested in diving in. But again, kind of the USD file format on that top left description, the fidelity of the avatar on the bottom left of the MetaHuman Creator, which is developed by Epic Games. We have, and on the right, we have the Omniverse kind of package. The top right is the Audio Two-Face interface, and the bottom right are all of the different applications and connectors that can be used to expedite and collaborate amongst different developers using different software solutions for their workflow. Part two. We discussed motion and how to apply these custom animations to the avatar to create more realism, both in the behavior of the avatar as well as the movement. So we talked about the OptiTrack motion tracking system we have in our lab that we used for our custom animations. We then learned about Motion Builder and how we use this tool as part of our workflow for retargeting and editing and interpolation. And then again, looked at Unreal Engine and how we added these to our sequencer, which we could apply the animations and blend these facial animations that we gathered from the previous seminar with the motion tracking. So again, if you just missed just a quick recap video on the top left again, but this is kind of the data that we're able to get from the OptiTrack system. We have that skeletal mesh, or that reconstruction, if you will. The top right is Motion Builder, allowing us to use the motion tracking data on top of our avatars mesh and drive that forward. On the bottom left, just that animation starter pack that we went over that are free and you can use to kind of experiment with. But we also talked about rigging and what that means and how we can use skeletal mesh or skeletal reconstructions to drive a mesh forward and to add some behavior and animations to it. So definitely check these two out if you've missed it. They're on our line, on our website, so feel free. So our 4-part series, or this is our 3rd part, and we'll be talking about haptics. So haptic technology, for those who don't know, refers to 3D touch. It is technology that allows users to physically interact with the virtual world. You can interact with virtual assets or even to add on to your immersive experience. Some of you may know haptic technology already within maybe a gaming controller of some sort with vibrations or even your smartphone. So haptic technology has already kind of embedded itself in today's technology that if you're unaware or aware. So not all haptic technology is the same. There are a number of different ways that creators have developed to interact with virtual worlds and assets other than our standard vibrations. Things like force feedback, for example, which we will see a little bit later today, that has a lot to do with kind of the haptic gloves that we'll discuss in a bit. Air vortex rings, for example, which are kind of donut-shaped air pockets made up of concentrated gusts of air. Both Microsoft and Disney have both taken part in this endeavor to kind of deliver non-contact haptic feedback. And there's kind of unique technologies and devices that are being incorporated now, like ultrasound, that uses focused ultrasound beams that can be used to create localized sense of pressure on a finger without touching any physical object. And I'll show you one of the devices in a second. and more. And again, there's a lot more investigation here, things like electrical stimulation, which you'll see in a second, but these are constantly growing. So it's very interesting to see where the development is taking place as we kind of think about interactions within virtual worlds. And so some of these, this is just a quick glimpse of some technologies in case you're unfamiliar. On that top left, you can see some haptic gloves. And this includes that force feedback on the fingers that restrict the movement of your hands to kind of manage the shape of the virtual object that you're interacting with. These can be very pricey, very costly. So, you know, a lot of companies and developers are starting to use these. However, you know, on a consumer-based level, it might be a little bit difficult to acquire, which is, you know, where Lucas may be able to shine some light on. We have on the bottom left these haptic suits. We actually had a demo here in the Immersion Lab using a suit called the Tesla suit, not related to Elon Musk in any way, but this allows you to kind of simulate through electrical stimulation certain objects or environments in the scene. For example, I was in the simulation where rain was falling, and I was able to feel almost a sense of raindrops on my shoulders, which really added to the immersive experience. And they've been doing a lot of training modules using this technology. And this is all incorporated in the body. So I think Tesla suit has over 100 different sensors, all the way from the shoulders to the bottom of the feet. So it can be very immersive, paired up with virtual reality. These technologies can really be very compelling. Then we have kind of this product on the top right that just came out called Emerge, which uses ultrasound to drive virtual objects and novel ways of interacting within each other. Here they use focus ultrasound beams, like I mentioned, to create localized sense pressures on the fingers. So those focal points that create the sensation of pressure is generated by individually controlling the phase and intensity of each transducer in an array of ultrasound transducers. So these beams can be used to deliver sensation of vibrations and give users the ability to feel virtual 3D objects. So this is a very unique way of interacting with your virtual worlds, if you will, and has allowed for real cool innovation content like Braille and you know, superpowers and all that kind of stuff. So very interesting space to consider as we think about haptics. And finally, again, just the typical hand controllers that you may not be familiar with, such as the Xbox controller or some of these new novel devices. And I do want to share one video of this new device that just came out in the space. And it's more of a one handheld controller that was developed by researchers from Korea, talking about kind of these skin slip around the fingertips. And I'll let them explain it here in this video.
How can you feel virtual objects in VR sliding through our fingertips? We developed a skin slip haptic feedback device using pivoting spinning discs and first evaluated user haptic perception of the device. We then investigated visual haptic congruency perception of skin slip direction and grip width perception in VR. We found that in VR, the visual feedback has a strong influence on how the haptic feedback is perceived. Please refer to our paper for details.
So I just wanted to show that because it is an interesting development.
How can you feel
it is interesting development how these new technologies and devices are starting to be thought about as kind of our devices become smaller and more portable, and what we can do and how to use them. And that brings me to kind of our use cases, where we kind of think of where we can go with these tools, how can they benefit us in different industries that are capitalizing on it. So again, these are just 4 examples, but there are a lot more. But I wanted to highlight these since aviation, for example, was kind of the beginning of haptic technology. It was actually first pioneered through aviation development and training exercises. One of the earliest applications was used in aircraft training. and in which aircraft approach a stall, for example, these vibrations was felt by the pilot's controls, and this was a useful warning of a dangerous flight condition. So, and they still use many of these practices today. Then, of course, it branches into more of that consumer market where we have all of those vibrational feedback in our pockets connected to our mobile devices. And this is still constantly being developed. Apple has released new patents on different ways to do multi-touch vibrations. So even though it's been around for a while, the way of translating the vibration is changing. And of course, along with that, with mobile devices, we have the gaming community where we use, simple haptic devices are common amongst the gaming controllers, the joysticks, and even steering wheels for immersive driving. This could also include that full body suits, like you saw in a second ago, along with kind of hands and feedback in the feet. So, this can be very compelling for a lot of game developers or gamers, if you will. And another example is also medicine and surgery, where training modules have been designed with force feedback and vibrational cues to indicate to training participants on best practices. And so a surgeon may be able to make an incision and they feel tactile and resistance biofeedback, or feedback rather, as if it was working directly on the patient. And they use this, remotely. They can train on their own. They have used it for veterinary clinics. So a lot of different avenues of space, and with medicine and training simulations, it seems to be where a lot of these technologies driving forward. So with that being said, I am then going to transition to Lucas, who is our guest speaker for today. As mentioned before, Lucas is a pioneer in the haptic field, building open source hardware and software that can be used so that you and I and other haptic enthusiasts would be able to participate in. So a lot of, our workshops, we do want you to do it yourself. And so I thought this was a great opportunity for you to all see what you could do in today's kind of day and age with the technology available. So without further ado, Lucas, feel free to take it away.
Yeah, thank you so much. And thank you so much for the opportunity to be here. I'm really excited to share all of this with you guys. My name's Lucas. I am a freshman here at MIT, and VR and haptics have completely taken over my life in the past year. I actually, about a year ago, December of 2020, was a high school senior taking a gap year. And I was stuck at home during quarantine, pretty much with no way of, seeing my friends. All of my friends were either also in quarantine or in college. I really, felt isolated physically. And that's kind of where I fell in love with VR as a way to extend beyond, my physical boundaries of where I was. And in doing that, I've found an amazing community of people who pretty much just like exist in VR, which is, fascinating as far as being able to, live your life in a place that's completely separated from our physical reality. And from there, I got really interested in, the technology that allows us to do that. I've seen, YouTube videos for a long time theorizing like, what is, the virtual human going to be like in the future? And, one of the things that's really interesting, like Talis mentioned, is those VR gloves that can actually let you feel virtual objects. And I had always really wanted to try those because currently VR headsets require you to use these, bulky controllers that, stay in the middle of your hand. You can't actually open and close your hands all the way. And you're always aware that this thing is in your hand and you're not actually interacting with real virtual objects. And so I really wanted to try those VR gloves. But of course, being just a high school senior, not really having any way of getting this enterprise grade tech or affording it even, I pretty much was out of luck. And so basically the only solution I had was to build them myself. And that's pretty much where I started. So I will share my screen here. And so pretty much this was the absolute start of the project. It was a couple of badge reels, like the kind that you would attach lanyards to, and some rings on my fingers, basically just to see like, could strings be used to measure and affect your fingers? And so the biggest challenge, I think for me, was that before you can have like a fully working VR haptic glove to interact with VR, you have to have like the position of your fingers, you have to have the position of your hand. There's a lot of data and motion capture that you actually need to do. And of course, I didn't have the, OptiTrack system or access to that kind of thing yet, because I was just a high school senior. So my solution was actually to take strings and attach them to potentiometers, which can measure the rotation of a shaft, which I eventually added a spool to and a spring. And so this was basically a super duper cheap way of just measuring the position of your finger using technology that's existed for a long time. And I think it's a really interesting pattern in this kind of VR hardware area, is that a lot of the really cool innovations aren't coming from making some, brand new groundbreaking technology. A lot of it is coming from taking things that have existed for a long time and just trying them out in ways that nobody has ever done before. And so basically what I did from there is I started adding more of them and seeing, like, can I actually use these to track my fingers? And I was posting videos on TikTok for a while, just as a way to like, share this with my friends who were, all the way in college already, and show, like, hey, here's, something cool that I'm working on. And the really interesting thing was the internet kind of fell in love with it. My first video that I posted had like 10 views, and the second one had like a couple hundred. And then by the third one, it was at like 400,000 views. Like, I don't even know what kind of exponential curve that is. That's beyond exponential, right? But then by the fourth video, I started adding, electronics to it to actually measure the positions of your fingers. And this one got to like 8.4 million views. And, a lot of people were expressing, excitement about, what this means for the VR community, for the VR industry. And so at this point I was hooked, right? Like at this point I was going to do anything I could to make these gloves, really work in VR. And so what I ended up doing was actually starting with Blender, which isn't really meant for this kind of work, but at the time it was, the closest to the software knowledge that I had to be able to get these to work to track fingers. And so you can see right here, it's actually tracking my thumb based on just that one sensor that I have there. And then later on, I added more of them. It originally was very buggy, but over time, I was able to improve it a lot. At this point, the electronics for just the finger tracking portion were about $11 per hand, which is significantly cheaper than most motion capture solutions for fingers. And of course, because it doesn't use cameras, it means you don't have to worry about occlusions. You could like put it behind your head or behind your back, and it would still track your fingers. But so using it in Blender was really cool as a demo, but it didn't actually, let you use it in virtual reality. And this is where actually the community came in extremely handy. So basically, in order to get this to work, I had to write what was called a SteamVR driver, which basically allows, or an OpenVR driver, which allows you to make external hardware work with OpenVR, which is one of the most at least readily accessible platforms for PC VR games. Because basically my big goal with this was to try to make the gloves work to be able to feel and interact with objects in video games that I was playing in virtual reality all the time anyway. And so I was able to get this driver to work, but it was extremely buggy. It took me a really long time. And overall, the process was of setting it up was not reliable at all. And so the really cool thing about this project is that because it's open and there's a really big community behind it, there were people who were willing to help me out just for the sake of them liking the project so much. And I think I really learned, don't underestimate the ability or the power of people who do unpaid work because they really love what they're doing, myself included, I guess. And so actually a high school student named Dan actually just reached out to me, and we decided to create this huge open source project for a VR glove driver that we eventually called Open Gloves. That is now totally available. You can download it for free on the Steam store. And all of the source code is online as well. So anybody can contribute to it and make it even better. And now it's at a point that the project is really stable. We're talking with Valve and getting support from them on how we can make it even better. But so from there, the biggest challenge was adding the haptics, right? So I had to compress all of the electronics down as much as I could to make the motors fit. And then eventually I started adding these force feedback motors. So these are just 9-gram servo motors, which are like $1 each to $1.50 each if you buy them in bulk. And so what I ended up doing was making it so that this spool that rotates when you open and close your finger can be limited by this servo motor. And it was very hard to actually make it all fit in one package at the time without being, super bulky. But eventually I got it to look like, let's see, right here. So this was now my 4th prototype of the VR glove, which now had that force feedback haptics. So you could actually feel the resistance and the shape of the objects that you hold in VR. And so those strings would actually pull your fingers back so that you could feel, the curvature of an object kind of, but more or less the size and shape. So like big things feel big, flat things will feel smaller. And it's one of those things that, of course, it doesn't give you every sensation that you have in VR. Obviously, it doesn't give you texture. It doesn't give you, complete, granular touch. But VR is one of those really interesting things where any amount of extra immersion you can add will go a long way when it's paired with the, visual stimulation from the headset. And so not only did we have to, use like a Unity code and things like that to make it work with the haptics, but then a big part of this project was also making it work inside of VR games, which is really difficult when we aren't the developers of the VR games. But this is another area where the community came really handy, which is that we can actually modify the VR games by making mods for the games and taking the basically the data inside of the game of the things that you touch and sending that data to the gloves so that you can actually feel the shape and the resistance of the objects. And so it might not necessarily be, the easiest thing to do for every single VR game out there, if you're just one person. But in having this community, I don't have to work alone on this because there are loads of other people in the community that are willing to dedicate their time, to help add the haptics into different games. So this is one that Dan and I worked on called Half-Life Alyx. Or the game is called Half-Life Alyx, and we made a mod for it that does this. And I believe I also have a video here of Boneworks, which is another very popular VR game.
To be you.
Oh. Okay, so Boneworks, another very popular VR game. And this one was actually totally community made, so I didn't even touch the code for this one. As far as the mod itself, and all of these mods. Oh. I think someone is flipping the share screen there. But basically, all of these mods take that data and they send it to that Open Gloves driver that I talked about, which then sends that data straight to the glove, which I also have one right here. And so the really cool thing about this is now the project is at a point that it's totally self-sustainable. Content for the project continues to grow, but not only that, there are people out there who are also building their own versions of the gloves. So the hardware is also open source. So anybody can go and, take my VR glove parts and go and 3D print them and build their own glove. Right now with the haptics, it's about $30 in parts per hand. So $60 total. And there are other people that have taken those parts and modified them to make them, fit whatever they want to do as well. So for example, here's a couple examples of people from our community that have made their own gloves. And they're growing every day, and people are also contributing software every day. So anytime someone has a feature on their gloves that isn't supported by our software, they can write the software themselves and then contribute it to our software to make it even better. So this is, just yet another example of, if you find the right community and the right people who are really interested in what you want to work on, you can, really further that kind of development much faster than if you were just working on your own. So yeah, I think as far as like the project itself, that's as far as the timeline for that. So I think from there, I'm happy to, jump right into Q&A.
Well, one of the questions, like, what's been the most surprising sort of community use? I mean, you had a certain set of things that you were trying to do, and the things that you're follow. But like, what's the surprising thing the community has decided to, hey, I'll try this?
Yeah, that's a great question. So right now, the majority of the community is other VR gamers who are trying to make this work into their games. But that's not to say that's everyone, right? So actually, one use that's been really interesting is there is a group of high school students in Barcelona who have built their own robotic hand, and they took my VR glove design and made some software to combine them so that you can control a VR glove, or you can control the robotic hand with the VR glove remotely from anywhere in the world. And what they also want to do is add like touch sensors on it. So you can actually feel objects that are in the robotic glove, with the goal of being able to shake someone's hand across the world. And so a couple of weeks ago, we actually got on a Zoom call and we shook hands remotely, which was, really amazing. And I think it was probably, one of the cheapest, applications of a telepresence robot that I've ever seen. So that was, really kudos to them because it was really exciting.
Oh, that's very cool. So participants, please feel free to chat your questions. Don't chat Rick Astley, but yeah, I'm not sure if he's has any haptic stuff in any of his prior videos or not. But so in terms of like, what's the sort of the most sort of the game that you enjoy interacting with the most, sort of with the haptic sense?
Yeah. So Boneworks, which is the second game I showed off in that video, has a really amazing physics engine. So you can do a lot of really powerful things with it, as far as being able to climb and actually feel the handholds that you're grabbing as you're climbing. And the developer that actually made the mod for that put a lot of time into making sure that every single object you pick up is the exact shape that the actual geometry of it is in the game. And so I think that's probably one of the biggest ones. For me, it's that game's a little tricky because it causes a lot of motion sickness for me. So I wish I could play it more. But I'm hoping, if there's, more VR games in the future that implement, similar kinds of physics engines, but without the same kind of emotion, then I'll be able to enjoy that a lot more.
So you're here at MIT, sort of being immersed in, sort of, as they say, as we like to say, drinking from the fire hose of the rate with which information comes at us. But what about, I mean, what do you see now as maybe some of the interesting opportunities for education? Whether it be at the college level or the sort of the elementary school level. Like how can this type of both the AR and VR, but haptics, enable some understanding, accelerated understanding for our learners?
Oh yeah, totally. So I would say like a big thing I struggled with in like math and physics classes previously was like having spatial reasoning based off of like a little like 3D, but really it's like 2D projected onto 3D sketch that you'll see on like a paper test or something like that. And I would say definitely one of those things where like, if you could just like put on an AR headset and like see, like, oh, this is like, like the Lorentz force law or whatever, and you can actually see it in 3 dimensions as opposed to like 2 dimensions and like a fake skewed 3rd dimension. In things like that, it would help a lot. I mean, and even just having like animations of, processes and things like that, for people who, really need to learn visually, or adding haptics, in a tactile way, being able to actually feel how, like 2 different forces slide along each other with variable friction, or, different concepts like that. I feel like if you're able to add that kind of technology in, would have a huge impact.
Let's see, here's a question. So are you planning to eventually make a basic kit for people to buy, meaning already assembled, maybe with injection molded parts instead of 3D printed? So what are your commercial plans, I guess?
Yeah, great question. So it's definitely one of those things that, if I'm able to do, I would, that's the dream, right? Because right now, the only people who can have these gloves are people who either, have a 3D printer and have the time to go and build them themselves, or they, can ask someone else to sell them to them, which that happens a lot on our Discord server. But I would definitely say, like, if that's something that, in the reasonable future I could do, I would be, ecstatic to be able to do it. It's also one of those things that, like, while drinking from the fire hose at MIT, it's very hard to find time to, fit all of those things in. But also there's a lot of really good resources here at MIT as far as like entrepreneurship and getting funding and things like that. So it's definitely one of those things that I'm looking into.
And to piggyback off that as well, I mean, the Immersion Lab is definitely open to kind of hosting some workshops for this creation and developing kits. So if there is a lot of interest, I strongly recommend those who are on the call today to feel free to email me or Lucas and provide your enthusiasm, and we will do our best to kind of create some kits. And we, once the COVID pandemic becomes to lighten up a little bit, we definitely have plans to do maybe a in lab kind of workshop, creating one of these hands. So stay tuned.
It's a very nice sort of elegant way. I think Lucas, there's probably some additional ways that the community can imagine using this in education, whether it be sort of conveying sort of both geometric concepts, but certainly sort of relative sort of force. You're not going to do the extreme forces of picking up something heavy, but sort of you can add a layer of intuition that is previously inaccessible in this type of without the haptic feedback. Let's see. You go for some more questions here from the audience, and just to sort of add on, here's a question: which haptic components need to be improved the most, both in terms of performance and in terms of cost?
Yeah, that's actually an excellent question. So right now, all of the haptics, which means basically just force feedback right now, is being done via 9-gram servo motors, which is great because they're extremely cost efficient. They're super cheap. They are not the most durable. So I'm using MG90Ss, which are metal geared at least, so you don't have to worry about gear stripping most of the time. But one of the problems is like if you lose like one tooth, then every single time it tries to close around an object, like it'll feel clicky as opposed to like a hard object. And so it's one of those things where like adding injection molded parts and having dedicated fabrication for all of those things, while it would have a much bigger overhead cost, so it'd require a lot of time to pay it off, is one of those things that would certainly make the gloves more durable and reliable over time.
Cool. There was a comment from one of the community members here. I could see them being used for organic chemistry or chemical engineering to explore molecules in space, sort of the geometrical arrangement, maybe how molecules fit together. Very nice. So another question here is how difficult, I mean, this speaks to the sort of the community assembling of them and maybe asking for a pre-assembled piece, but how difficult, what do you say it is to make a pair of gloves? I guess it depends on the skills you have, the tools you have, but how difficult is it?
So I would definitely say the tools is a big part, because you can just do it like with like DuPont wires and like breadboards and like basically anything that would come in like a basic Arduino kit, and it'll probably work great. The one problem you'll have is like the wires might fall out of the pins and things like that on the potentiometers. It's one of those things where like if you have a nice crimp set or you use like a soldering iron for it, it'll make it significantly easier to build, as long as you know how to use those tools. And as far as our community goes, we don't have specific data on like how many people have built the gloves, but what we do have data on is how many people have downloaded the driver, which is required to build, use the gloves in VR. And so we have a few thousand downloads of the driver, which means, some subset of that, a few thousand people have built the gloves themselves. And the great thing is because we have this community, anytime you're building your own gloves and you run into a hiccup, you can pretty much just go on our Discord server and say, like, help, I'm stuck on this part. And there will be, multiple people who are really excited to help out and help other people build the gloves.
There's just some comments here as I'm reading through them. I think some people are highlighting, for example, some electroreactive polymers, sort of shape memory alloys, but other potential ways of inducing both measurement and actuation. That might be smaller form factors that might be interesting to explore. I guess maybe one last comment here, maybe get your sort of thoughts on this. And certainly as we think about robotics, there is this evolution, very, very rapid revolution, people looking at sort of flexible and soft robotics, things that aren't just rigid, sort of fixed structures. Do you see this as sort of in the context of haptic devices? Do you see this in a similar way, that it's certainly there's some rigid components in your glove, but you really want it to be a soft, flexible thing? Like how are you informed, I guess, maybe by the things that may be happening in soft robotics or flexible other areas where flexible things are being used for actuation and control?
Yeah, so interfacing with the human body, I think, is one of the biggest challenges of this project, because humans aren't like this rigid object that you can just like snap things onto easily. Like humans are squishy, they have stretchy skin and things like that, but also all humans are a different size, right? So like if I were to take my gloves that I built for my hands, especially the original prototypes, which were just like pure plastic, and tried to fit them on somebody else's hand, it was a really big challenge to actually get it to fit, because everyone has different sized hands and fingers and things like that. And so being able to switch to like, I've been experimenting with like TPU pieces so that, you have like flexible rings and things like that. But even I know like a lot of companies like Haptics and even Meta now are experimenting with using like microfluidics for like touch haptics. So you have like these little squishy bubbles that will like expand and let you feel textures. I think it's definitely one of those things that is probably going to become more common in the future. But because that tech is still really big and hasn't been, innovated to the point at which you can just like put it in your pocket or put it around your hand, it's one of those things that's still going to take time to get there.
Well, Lucas, I very much look forward to sort of supporting you at the Immersion Lab and figuring out a way to help you sort of further connect with community on campus and off campus. Talis, any other sort of comments you want to make before we close out for the day?
Yeah, I'll just kind of finish up. Lucas, thank you so much for joining and sharing your experience. And the idea is to really this is a workshop designed to kind of allow you guys to all create and experience the metaverse together with kind of do-it-yourself technology. So just like the first two, we had that take-home lab to kind of go do the experience yourselves. I strongly recommend. I posted a link in chat to kind of the Lucid Gloves VR, kind of the documentation and all of the parts that are needed. So just feel free to experiment if you guys are ever interested in the space. And let me share my screen real quick just to kind of end this out. And so our next Immerse series will be taking place in the summer. So once you guys, once we finalize the date, we'll be posting that on our website. And this will be all about virtual worlds. So kind of the VR experiences that we can create. How does this relate to the metaverse? And specifically the current research that is being developed, both at other academic institutions, as well as Meta and all of these different labs that are really looking to ingrain a lot of these tools in our everyday life. And how does this shape our different lifestyles, and is it here for the better? So hopefully you guys will be able to make that. Thank you all for following along for the third part, and we look forward to seeing you guys. So thank you again, and we'll talk soon.
And Lucas, thank you again for your engagement with the community, your willingness to come today, and for phenomenal work. So looking forward to continued interesting and great things from you. So Talis and Lucas, have a great remainder of your day. Participants, have a great day, and thank you and stay safe.
Thank you.
Thank you.